The Fibonacci sequence satisfies the recurrence relation f sub k equals f sub k minus 1 plus f sub k minus 2 for every integer k greater than or equal to 2. Explain why the following is true. F sub k plus 1 equals f sub k plus f sub k minus 1 for every integer k greater than or equal to 1. Now, if you notice, these two recursive definitions might look like they're the same, but the index here, the index variable k, which is used to evaluate the subscripts in this recurrence relation, is shifted by 1 unit. There's not much to explain why these are the same. Now, k is universally quantified. So let's plug in k equals 2 here. The first instance of this recurrence relation says that f sub 2 equals f sub 2 minus 1 plus f sub 2 minus 2, which is the same thing as saying that f sub 2 equals f sub 1 plus f sub 0. This is the first instance of the Fibonacci recurrence relation being applied. Now, under this recurrence relation, we can plug in values as low as k equals 1. So if we plug in k equals 1 into this recurrence relation, we get f sub 1 plus 1 equals f sub 1 plus f sub 1 minus 1. But this is the same thing as saying f sub 2 equals f sub 1 plus f sub 0. These are the same recurrence relations. The only difference is that the index is shifted by 1. However, the universal quantifier is properly adjusted as well. So if the green recurrence relation is true for every integer k greater than or equal to 2, then the purple relation must be true for each integer k greater than or equal to 1. And that's because of that shift. So that's part A. Part B says write an equation expressing f sub k plus 2 in terms of f sub k plus 1 and f sub k. Well, we can apply essentially the same trick here. We could say f sub k plus 2 equals f sub k plus 1 plus f sub k. But we have to be careful about the quantifier on k. We want to say this is true for every integer k greater than or equal to a very specific number here. Now, the first instance of this recurrence relation should be that f sub 2 equals f sub 1 plus f sub 0. But that would only work if we start at k equals 0. So k has to be greater than or equal to 0 in order for this recurrence relation to be the same. And part C is more or less the same thing with part B. With part C, we could say f sub k plus 3 is the sum of the two previous terms, which in this case would be f sub k plus 2 plus f sub k plus 1. But if we want this to be the same recurrence relation, we have to adjust the universal quantifier just a little bit. In this case, we want to say that k is greater than or equal to -1, which feels a little weird because most of the statements that we've been working with are true for every integer n greater than or equal to 0, or n greater than or equal to 2, or n greater than or equal to 3. But this would be true for every integer k greater than or equal to -1. So thanks, everyone, and I'll see you in the next video.